right, so section 5.4, we're getting into something called function notation. In short, we are basically writing the equation of the slope-intercept form, y equals mx plus b, as f of x equals mx plus b. This and this are basically the same thing, and f of x is just another way of saying y. This confuses a lot of students. I don't know how to make it any simpler. F of x is the same as y. It's the same thing. Don't get this overly confused. You treat it just like you would if you had a y equals mx plus b. All right, so you've already heard me saying this out of habit. This right here, f parentheses with an x in it, is read as f of x. So if I were to give you this, don't freak out, it's saying g of x, and it's still basically giving me saying y. All right, so this is another thing you need to understand. If x values are the domain, which we know to be true because generally your x are your inputs and your independent variables, that means that the f of x is your range because y. F of x is y. And therefore, because it's the y, it's your range, it represents your dependent variable, it represents your output. So don't get overly confused of this. When you think f of x, you just need to think of, hey, y. So let's just go ahead and give you an example here. It says evaluating a function. It's telling me to evaluate f of x equals negative 4x plus 7 when x is equal to 2. Now, let's just stop here. I'm going to kind of do some parallels. All right? I want to do a little bit of a parallel here. Let's rewrite this just so you can see and change f of x to equal to y equals negative 4x plus 7. All right, so that you have this, I want you to see it's literally the same thing. When I know my equation and I'm trying to evaluate it for when x is 2, I basically plug it in. Y is equal to negative 4 times 2 plus 7. Y is equal to negative 8 plus 7 because negative 4 times 2 is negative 8. Add that together, I get y is equal to negative 1. Perfect. Easy. We have evaluated this equation when x is equal to 2. Now let's do the same thing. F of x is equal to negative 4x plus 7. I do the exact same thing. Every time I see a x, I put 2. So watch what I do here. I'm going to keep my f and I'm going to put a 2 here. So f of 2 is equal to negative 4 times 2 plus 7. Now notice that I just kept bringing my y down. I'm literally going to do the same thing here. I'm going to say f of 2 is equal to negative 8 plus 7. And then I'm going to say f of 2 is equal to negative 1. Notice how literally they are the same exact thing. The only difference is instead of having a y here, I'm actually having my f of x in there. I'm having my function notation. I am saying when x is 2, when the function, this function right here, when I know that x is 2, the function, the f of 2 is equal to negative 1. I've just solved and evaluated this function. So it's the same thing here. I have f of x is equal to negative 10x minus 60. I am going to plug negative 7 everywhere I see x. So f of negative 7 is equal to negative 10 times negative 7 minus 60. F of 7, negative 7, this does not change. You are not doing anything with it. You keep this just like it is equal to positive 70 minus 60. And then continue to simplify and solve and evaluate this equation, and you find out that f of 7 is equal to 10. And what we're doing is we're basically saying, what is this equation when x is equal to negative 7? We just plug it in and solve. And notice how the f of 7 never goes away. All right, so let's look at number 1 on the next page, a little other example. It says find the value of x so that the function has the given value. So I'm going to do kind of the same exact thing. I'm going to try to do this all in one line. And I'm going to have a one line that says g of x is equal to 8x minus 11. And then on this side, I'm going to say y is equal to 8x minus 11. Now notice this. It gives you the equation g of x, this function, g of x is equal 8x minus 11. And then it says that g of x is equal to 5. So another way that this is being said is that y is equal to 5. Knowing this, let's plug 5 into this equation. 5 is equal to 8x minus 11. We're going to solve for it. We're going to add 11 to both sides, and I get 16 equals 8x, because I added 11 to both sides. And now I'm going to divide by 8 on both sides, and I get 2 is equal to x. So when y is 5, that means that x happens to be 2. We're going to do that same exact thing. G of x is equal to 5. So I'm going to replace this entire g of x with 5. And then we're going to work it out. And look, automatically, it's literally the same thing. So now we add 11 to both sides, and I get 16 is equal to 8x, literally the same thing. And then I'm going to divide by 8 on both sides, and I get that 2 is equal to x. And that's literally the same thing. There's nothing changing. So what you just found out as this, when g of x is 5, that means that x happens to be 2. All right? That's it. That's all this is. So it's the same concept here. Now I'm just going to work it out. I know f of x is equal to negative 2x minus 12. And I know that f of x is equal to 12. So I'm going to take this whole thing and I'm going to replace f of x and say 12 is equal to negative 2x minus 2. Then I'm going to solve. I'm going to add 2 to both sides, and I get 14 is equal to negative 2x. Now I'm going to divide by negative 2 on both sides, and I get that negative 7 is equal to x. I am done. And we can verify this. We can prove it. How do we do it? Well, just like we always do, we check it. We know that we are trying to get v of x is equal to 12. So we're going to write that original equation down. I'm running off screen here. We're going to write that original equation down, and this time we're going to put negative 7 in the place of x. So if we did this right, v of negative 7 is equal to negative 2 times negative 7 minus 2. v of negative 7 is equal to 14 minus 2. v of negative 7 is equal to a positive 12. Is that true? Did that match with what we were wanting to do, that v of x equals 12? Yes, it does. It does work. All right, so with that said, why don't you try number 3 and number 4 on your own? What you should have got for number 3 and number 4 was that x is equal to negative 6 and x is equal to 1/4. If you're stuck on this, you know how to find me. Please come ask questions. All right, number 5 should not be too much of a problem. It says graph the linear function. Hey, guess what? This is the same thing as graphing a y equals negative 3x plus 1. We treat it the same way. So we know, according to this, that my y-intercept happens to be at 1, and that I have a slope of negative 3, meaning that my slope is negative 3 over positive 1. So I'm going to go down 1, 2, 3, and to my right 1. And I'm going off the screen a little bit, or off the chart, or I can go in reverse, and I would get here. And now that I do that, I'll use my handy dandy straight edge. And there's my line. All right. Same thing with number 6. I have a y-intercept of negative 2, and it's got a positive 1, so I'm going to go up 1 and to the right 4. 1, 2, 3, 4. And I need to do the same thing in the opposite direction, so I work backwards, and I would get to there, and then I would do my line again. All right, so this is literally not changing anything that you have done in the past. It is just a continuation with it, and all you're doing is changing the y, in this case, to h of x, and you're changing this one to f of x, it's still literally the same exact type of problem. All right, so number 7. You have $124. You earn $22 each time you mow your neighbor's lawn. Here is the function. S of x is equal to 22x plus 124, and that represents your total savings. What will your savings be after you mow 5 times? Well, this is the thing. So you know that x is going to represent how much you mow because it says 22 each time you mow. So all you're going to do is S of 5, my S's and 5's look alike, is equal to 22 times 5 plus 124. And we basically are going to work that problem out. So let's do a little bit of math. I don't feel like doing it on calculator. S of 5 is equal to 22 times 5 is going to be 110. I was right in my head. Plus 124. We're going to combine those. So S of 5 is equal to 110 plus 124 equals $234. So after 5 times, you're going to get $234. Again, this doesn't change anything. It should be very familiar. Now, look at this next one. It says, how many times do you have to mow to save a total of $300? So you need to recall that S of X represents your total money that you're trying to save. So all you're going to do is use the same equation, but this time you're going to put 300 in the place of S of X, and you're going to solve for X. All right, so when we do, subtract 124 from both sides, and we get that 300 minus 124 is equal to 176, is equal to 22x, divide by 22 on both sides, and we find out that x is equal to 8. So you have to mow 8 times in order for you to get a total of $300. That's it, guys. That's all 5.4 is. All you're doing is changing y into f of x or g of x or to whatever function notation it may say. You still treat it like it's y. You don't change any procedures that you've learned in this class. It stays the same. So just be willing to understand that things like this can be interchanged. All you have to do is realize that h of x is the same thing as y. And that's it, guys. You know what to do. You got questions, I got answers, and I will see you in the next video. Bye-bye.